a demonstration that illustrates the differences in conductivity of strong electrolytes, weak electrolytes, and non-electrolytes. In this first beaker is table salt, or sodium chloride. And sodium chloride is an ionic solid, and ionic compounds are made up of ions, and when we add water to them, they dissolve and form individual ions. So we're going to stir the solution to get the table salt to dissolve. We're now going to take a conductivity meter and place it into the beaker. We can see that the conductivity meter is very bright and is also blinking. This indicates a high concentration of ions in solution, which means that table salt is a strong electrolyte. I'm going to rinse off the conductivity meter in distilled water. And the next beaker contains hydrochloric acid. Hydrochloric acid is a strong acid, and strong acids dissociate into their ions. So when we place the conductivity meter into the hydrochloric acid, we can see that the conductivity meter, again, is very bright and blinking. This indicates that there's a high concentration of ions in solution, and that HCl is also a strong electrolyte. We're going to rinse off the electrode again. The next solution is acetic acid, more commonly known as vinegar. Acetic acid is a weak acid, and weak acids only partially dissociate into their ions. And so what we can see by placing the conductivity meter into the solution of acetic acid is that it is very dim. And this dimness indicates that there is a small concentration of ions, and therefore acetic acid is a weak electrolyte. I'm going to rinse off the conductivity meter one more time. And the beaker, that is the last one, contains sucrose, which is commonly known as table sugar. We're going to dissolve that in water as well. And sucrose is a covalent compound. Covalent compounds do not break up into their ions. And so what we're going to find when we place the conductivity meter into the solution of sucrose is that it is not lit up. This indicates that there are no ions in solution and that sucrose is a non-electrolyte.